Hello dear students, today we will learn a very important topic, that is combination of capacitors. So first of all we will discuss the theory part a little bit. It's like one shot, and then we will discuss the entire thing based on combination of capacitors. So let's start. Combination of capacitors, there are basically two types of combination. One is called series combination and another one is called parallel combination. So for series combination, the circuit looks like that. This is basically the circuit. Let's say the last one is grounded. So this one is C1, this one is C2, this one C3 and C4 and so on. There may be more than 4 capacitors, as you know. So now in series, what happened? All of the capacitors have same amount of charge. So all of the capacitors have equal amount of charge Q. But their potential difference, that means the potential difference of the first capacitor, just suppose it is V1, for the second one it is V2, for the third one it is V3, and for the fourth one it is V4. So the potential difference or terminal potential difference or the potential difference between the two ends of a capacitor are different when they are connected in series, but their charges are same. All of them have equal amount of charge, but their potential difference are different. This is the concept for series combination. And equivalent capacitance, 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4. This is the formula. Now we will talk about parallel combination of capacitors. Okay. Now we will talk about parallel combination of capacitors. This circuit looks like that. This is one capacitor, this is another, this is another. Suppose this is C1, this is C2, this is C3. So what's happened here? Just look the circuit carefully. Let's say the last one is grounded. It may be grounded or not, it doesn't matter. Okay. So here all these capacitors are connected in parallel. So imagine that if V1 is the potential difference between the two ends of the first capacitor C1, then definitely that V1 will also be the potential difference between the two ends of the capacitor C2. Similarly, that V1, here we are talking about that V1 is the potential difference. You can say only V is the potential difference between the two ends of first capacitor. Similarly, then V will also be the potential difference between the two ends of the second capacitor C2, as well as V will be the potential difference between the two ends of the capacitor C3. So it's very easy that the potential difference between the two ends of the capacitors will be same when all of them are connected in parallel, but their charges will be different. Suppose this capacitor has Q1 amount of charge, this has Q2 amount of charge, and this has Q3 amount of charge. But so what is the concept? That when they are connected in parallel, their value of charges will be different, but their potential difference will be same. This is the concept. And what is the formula? C equivalent equal to C1 plus C2 plus C3. This is the formula, and for large number of capacitors, the formula will extend it. That's it. Now I will explain few things. Just like we all know, what is Ohm's law? Actually, Ohm's law told that whenever there is a potential difference, let's say it is a wire having resistance R, and the potential of that end is V1 and the potential of that end is V2. So if V1 is greater than V2, then current will flow in this direction, and the current will be directly proportional to the potential difference between the two ends. Okay. Let's say V1 minus V2 is equal to V is directly proportional to I. So V is equal to I into R is a constant, where V is basically the potential difference between the two ends of the conductor. So according to Ohm's law, if there is no potential difference between the two ends of the conductor, no current will flow. Just see here, the potential difference is directly proportional to the current flows through it. So if there is no potential difference between the two ends of a conductor, then no current flows through it. This is the concept. And one more thing that you have to understand here, that in electronic circuit, all the points are basically represented by its value of potential. Actually, in social life, just we will take one very easy example. In social life, if I give you one task that you have to go in a particular village, and then you have to find all the persons those that belong from same family. Just say that they don't live in a particular house, they live in different house inside a particular village. Now your task is you have to find all the persons who belongs from a particular family. So how you will find them? Actually, in social life, you will just test their DNA. Those persons whose DNA sample will match, they belong from same family. That's it. Because for a particular family, all of their DNA sample will matches. Similarly, here we will verify, we will judge any point on the value of its potential. Just try to understand here. Just A and B are two persons, and if their DNA sample matches, that means they belong from same family. They are from same particular family. And if their DNA sample does not matches, that means they don't belong from same family. Similarly, if there are any 2 points in electronic circuit whose potentials are same, suppose A is a point and B is another point, the value of potential of point A is V, as well as the value of potential of point B is also V. That means actually these 2 points are called equipotential points, and in electronic circuit, when 2 points have equal potential, they are basically same points. They are basically same points. Just like when two persons DNA will matches, that means they belong from same family. Similarly, when the potential of 2 points are same, that means they belong from, actually not they belong from same family here. Actually, these 2 points are called equipotential points. That means we can consider that these 2 points are same points. Okay. So what is the rule? When the potential of 2 points are same, then they are basically same points. And when there is no potential difference, no current will flow through it. And one more thing, in practical life, just imagine if there is one person, very handsome, very good body shape, but he's dead. Now it's meaningless, sir, because we all know that this body has no importance without life, without the life. So life or soul is the main thing. Similarly, in electronic circuit, if there is any electrical components, any electrical equipments, and no current flows through it, that means it doesn't have any importance. So what is the meaning? In electronic circuit, if there is no current flows through any part of the circuit, then we will directly neglect it. Because if in electronic circuit, when current will not flow through it, then there is no importance of that particular equipment, of that particular component. So similarly, now we can say that when any 2 points, just imagine that A and B are 2 points. When any 2 points are connected directly by a wire, when any 2 points are connected directly by a wire, so here A and B are 2 points which are connected directly by a wire, then these 2 points are called short. Short means when any 2 points are connected directly by a wire, then these 2 points are called, they are short. Okay. So if there is any type of electrical equipment, so if there is a capacitor between these 2 points, or there is a resistor between these 2 points, or there is an inductor, or there is any other battery between these 2 points. So when there is no electrical equipments connected between 2 points, they are just connected by a normal wire, then these points are called short. Short means the value of potential of both the points are same. Why? Because they are connected by a normal conducting wire. Just because they are normally connected by a conducting wire. So if there is no electrical equipments, so you can consider that they are directly connected. I am telling that thing again and again. Okay. So if there is any electrical equipments, then they will not be equipotential points, because they will not be short point anymore. The potential of that point and the potential of that point will be different. If any 2 points C and D are directly connected by a wire, then we can consider the potential of that point and that point are same, just because they are directly connected. So this is the concept. This is the concept that we will use throughout the solving of numerical, and let's see how easily we will solve all those numerical. Let's start. We will take examples, and I believe within few examples you will be able to solve all those problems by yourself. So let's take some problems. First of all, number 1, just imagine this is a combination. This is a combination. This is a combination. Okay. This is 2 microfarad, this is 2 microfarad, this is 1 microfarad, this is 2 microfarad. So the question is, you have to find the equivalent capacitance between the points A and B. So how you will calculate? The strategy that we follow here, you have to take these 2 points with between which you will calculate the equivalent capacitance. This is A and this is B. Just take these 2 points in this way. So now if this point is A, that means the potential of that point is VA. Similarly, the potential of that point will also be VA. Why? Because these 2 points are directly connected by a wire. There is no electrical equipments connected between them, as I told. So we can also consider this point is also A. If this is B, we can also consider this point is also B. So what is the circuit here? 2 microfarad capacitor. This is 1 microfarad. 2 microfarad capacitor is connected between A and B. Similarly, 1 microfarad capacitor is connected between A and B. So how we will write here? Just add them very easily. So this one is suppose 1, this one is suppose 2, and these 2 and 2 are connected. This is very simple. They are connected in series. So when 2 and 2 are connected in series, then the value will be 1. So this is 1. So now all of them are connected in parallel. So what will be the answer? All of them you have to add. So equivalent capacitance between the points A and B will be 1 plus 1 plus 2. That means 4 microfarad. That's it. Now we'll give another one. Okay. Now let's see the second one. Now the second one is very simple. It's pentagon shape. What we'll do? This point is P, this one is Q, this one is R, this one is S, this one is T. And the first question is, find the equivalent capacitance between the points P and Q. So how we will calculate? As I told, you have to take these 2 points P and Q. P and Q. Now just see this circuit. Here the value of capacitance of all these capacitors are C. So just see these points. Actually, one capacitor is connected between C and B directly. Sorry, P and Q directly. This is P, this is Q. One capacitor is connected directly. So this is the capacitor cell. Now P and Q, one capacitor is connected. And let's see another way. 1, 2, 3, 4. We can also go P to Q in this way. So you will just do that thing. 1, 1, 2, 3, 4. 1, 2, 3, 4. Just see here. Just see here. From P to Q directly connected, and from P to Q we can also go by these 4 capacitors. So what will be the value? Now these 4, all of these values are C. So these 4 are connected in. These 4 capacitors are connected in. These 4 capacitors are connected in series. So what will be the value? The value will be. What will be the value? That one is C and that one will be C by 4. That one will be C by 4. So what will be the answer? C by 4, because 1 by C plus 1 by C plus 1 by C. C is the LCM, 4 by C, and when you will just take the reciprocal, that will be C by 4. So CPQ will be C by 4 plus C. That means 5C by 4. So that is the answer. 5C by 4. Now in the same question, they ask you, find the equivalent capacitance between the points P and R. I think now all of you will be able to solve that one. So now we will take these 2 points P and R in this way. So now P and R, they are connected directly by 2 capacitors. P to Q, Q to R. So P to Q, Q to R. This is P to R. Similarly, from P to T, T to S, S to R. That easy. So now what it will look like? There are 2 capacitors, P to R. Everyone will be able to solve now. So this is basically C by 3 and this is basically C by 2. Now they are connected in parallel. You just have to add these 2 values. Clear? Now calculate this value and comment what is the answer. And third one, let's solve the third one. This is a capacitor. All those values are 4 microfarad, 4 microfarad, 4 microfarad. That one is also 4 and that one is 2. Okay. So the question is, you have to find the equivalent capacitance between this point A and this point B. So what are the rules? If sir this point is B, then also that point will also be B. Sir, if this is B, will that point will also be B? No, no, no. Why? Because between this point and this point, one electrical equipment's capacitor is connected. If that capacitor was not there, only they are connected by a normal wire, then the potential of these 2 points are same. That is why if this point and this point, at that time they will be same. But now they will not be same. So this is P, this is another point. Another point, this is B, this is another point P. This is also P because these two are connected directly. So these two capacitors just connected in parallel. Now instead of these two things, we can write only one. So its value will be 6. A to B. Just like this is A, this is B. So we can go A to B 4, 6 in this way, as well as 4, 4. 4, 4 in this way. Now I think these two are connected in series. So the upper part will be, they are connected in series. So the answer will be 24 by 10. 24 by 10 means 2.4, and the below part, that will be, this is also 4, that will be 2. That will be 2. So when you will add all of those two things, then the answer will be 4.4 microfarad. Now let's take the third one. So sorry, now we will take the fourth one. So what will be fourth? This is the value. This is 2, this is 2, this is 2. Sorry, this is also 2. Now you just add these two things. You have to find the equivalent capacitance between the points A and B. Let's see, these two capacitors are connected in parallel. So what will be the value? Instead of these two, we can write only 1, and then the value will be 2 connected in parallel. So that will be 4 because they are connected in parallel. So now you have to calculate equivalent capacitance between the points A and B. Just take, this is A and this is B. This is A, this is B. So 4 is directly connected between A and B. So this is where 4 is directly connected between A and B. This is 4, okay. That one is 4. 4 is directly connected between A and B. And from A to B, from A to B or B to A, 2 more capacitors are there. 2. This is equal. This is 2, this is 2. So what will be the answer here? The answer will be A, the upper part is 4. This is B, and that will be 1. So the answer will be 5 microfarad. That will be the next example. Here we'll take the next example. How we'll solve it? This is quite easy and interesting. So this is 2, this is 2. That one is also 2, but that point is grounded, okay? That one is also 2, but that point is grounded. Now how we will solve it? Here this is A and this is B. So now similarly, these two capacitors are connected in parallel. So instead of these two, we can write only 1, and that value will be 4. Okay. So now sir, what we will do? Actually, just see carefully. This point is grounded, this point is grounded. That means the potential of that point is 0 because it is grounded. Similarly, the potential of that point is also 0 because it is also grounded. That means the potential of that point and that point are same. That means if you write this is P, this is Q, then P and Q are identically same, because just I told in electronic circuit the value of potentials of any 2 points are same, then we can consider them same points. So here P and Q are same. So what we will do? Actually, this is sir A, this is B. 4 ohm is 4 microfarad is directly connected between A and B, and from A, let's P and Q are same point. So if P and Q are same, then we can add them. No problem is there. So this is 2, this is also 2, this is 4. So what will be the answer? Here also the answer will be 5 microfarad. Okay. Just see again, I am telling that thing. Potential of that point is 0, potential of that point is 0. So their potentials are same. And in electronic circuit, if the values of potentials of any 2 points are same, then you can consider them identical point. That means P and Q are same. And we also know that when 2 points are directly connected by a wire, that means they are shorted, then also their potentials are same. That is why we can consider that they are connected by a wire. Okay. Now we'll do the next example. So it will be easier for all of you if you solve them by yourself. So that one. So first do the easier thing. So that one and that one. So what you will do? This is A, this is B. Each of capacitance C. You have to find the equivalent capacitance between the points A and B. What you will do? So if this point is A, that will also be A. Why? Because these 2 points are directly connected by a wire. That means these 2 points are shorted. No electrical equipment is there. So if it is A, then also that point will also be A. Why? Because these 2 points are directly connected by a wire. No electrical equipment is there. And sir, it is B, so it will also be B. That point will also be B. Now this is A, this is B. A to B, one. A to B, another one. A to B, another one. That means all these 3 are connected between A to B. So how they will be connected? This is the only way. So the answer will be 3C, each of capacitance C. Now we will do the next one. Is it clear for everyone? Or it is looking harder or difficult? Let's see, we'll take few more examples. I believe then things will be very easy for all of you. So this is another one. This is another one. So we'll take these two. They're shorted as well as these two are shorted. Okay. Now you have to find the equivalent capacitance. 1, 2, 3, 4, 5 capacitors are there. So this point is A, this point is B. All the capacitors having same capacitance C. So how we will solve it? So if this point is A, that means potential of that point is VA, then the potential of that point will also be VA. No. If this point is A, then that point will not be A. Why? Because between this point and this point, capacitor is present. And I just told that if there is any type of electrical equipment, present between 2 points, then they will not be shorted. Their potentials will not be same. There will be a potential difference, and whenever there is a potential difference, you can't consider them same or identical points. If they are directly connected by a wire, then their potentials will be same. They will be called, they are shorted, and then you can consider these 2 points same. Clear? So now this is A, this is different point. Let's say this is P. If this is P, that point will also be. This is B. Let's say this is another point Q. If this is Q, that will also be Q. Now this point is A, as I told, this point is B. From A, one capacitor goes to P. This point is P, that one is P. P to Q, P to Q, or Q to P, P to Q. That means these 3 capacitors are directly connected between P to Q. And from B also one capacitor is there. This is called Q. And from P to Q there are these 3 capacitors. Is it clear for everyone? So what will be the answer here? So this is A, this is C. That will be 3C because they are connected in parallel, and that one will be C. So now I think they are connected in series. You just have to find the values of, you just have to solve this. Okay, they are connected in series. I don't think that now this is difficult for you. Okay, so now for the next one, just imagine these are 3 capacitors. These are 3 capacitors. So they are directly connected in this way. Each of capacitance C. Okay, each of capacitance C. You have to find the equivalent capacitance between A and B. So what you will do here? If this point is A, that will also be A, but that one will not be A. Let's say this is a different point P. If this one is B, that one will also be B, but that one will not be B. Why? Because one electrical equipment is there. Let's say this is Q. So now what you will do? So this is A, this is B. Just see, from A, directly 2 capacitors are connected. This one is directly connected with A, and that one is also directly connected to A. So we can write this in this way, that this point is P and this point is Q, let's say, and between P and Q one capacitor is there, and from B to P one is there, from B to P another one is, from B to Q. So that one is B to Q. So actually this is basically balanced Wheatstone bridge because the capacitance of all of them are same. Actually, we know, I think we all know what is balanced Wheatstone bridge. If you don't know, then sorry, we'll discuss it in other videos, because now it will not be possible to talking about Wheatstone bridge. Wheatstone bridge is a special type of circuit, and its balance conditions, it means the ratio of the resistance or capacitance of these two arms and these two arms will be same. So here all the capacitors having value C. So that is why for Wheatstone bridge, what is the rule? When the Wheatstone bridge will be at balanced condition, then the potential of that point and potential of that point will be same. Now just imagine if the potential of that point and that point is same, that means there is no potential difference between these 2 points. That means if there is no potential difference between these 2 points, when a Wheatstone bridge at its balanced condition, then the value of potential of these 2 points are same. So when there is no potential difference between these 2 points, then no current will flow through it. That means according to Ohm's law, if there is no potential difference, no current flows through it. And in electrical circuit, if there is no current flows through any electrical equipment, you just neglect it. Just like a body which is very good looking, but no life or soul is there. So we just ignore it because no importance is there. Similar thing in electrical equipments, if no current flows through the electrical components or equipments, you just ignore it. So we'll just ignore that thing. So what will be the combination of circuit that will looks like this: C, 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 C. That point is P, that point is Q. So what will be? That will be then C. C are series. This is C, this is C, and that one is gone because the potentials of these 2 points are same. So we can neglect it. So these C and C, they are connected in series. So what will be the value? C by 2. They are also connected in series, C by 2. So the answer will be CAB, equivalent capacitance will be C only. C by 2 plus C by 2. Okay. C by 2. Now we will take the next example. Okay. Now we'll take the next example. So let's see, this is a circuit. This is a circuit. This is 2. This point is B. That one is also 2. Now, actually, this is the battery. This is 2. This is 2 by 3 microfarad. This is 2 by 3 microfarad. And this is a 4-volt battery. And that point is A. You have to find the potential difference between the points A and B. Equivalent capacitance between the points A and B. So how we will solve it? You have to find the equivalent capacitance between the points A and B. Let's solve this way. So if this point is B, then that will not be B, because between these 2 points one capacitor is connected. Let's say this is P. So that will also be P. Directly connected. That will be P. That will be P. That will be P. That will be P. So very funny. So we have to take A and B. These are the 2 endpoints. How we'll connect them? From A to P, both these capacitors are connected from A to P, and B to P. So let's say that point is P. So A to P, 2 by 3, 2 by 3. B to P, 2. This is another 2. This one is B. This is also 2. Now let's also connect the battery here. So that is the circuit. That is the circuit. Is there anything? These 2 are connected in parallel. These 2 are connected in parallel. So the answer will be 4 by 3. And these 2 are connected in parallel. So the answer will be 4. So what it will be? A. That one is 4 by 3. And that one is 4. And they are connected in series only. They are connected in series only. I believe everybody will be able to calculate what will be the value of the series combination of those 2 capacitors. Now we will solve few more numericals on the basis of that. As I told, it's my promise, you will be able to solve any type of numericals on the basis of capacitors. Let's take that one. That one is quite funny. That one is quite funny, but very easy. Let's say this is M point and this is N point. So one capacitor is connected. This is C, and from that point, this is also C. This is also C. That one is also C. The capacitance of all those capacitors are C. You have to find the equivalent capacitance between the points M and N. How will solve it? So if this point is M, that one will also be M. That one will also be M. That one will also be N. If this is M, that will be different point P. So now just you have to find the equivalent capacitance between M and N. Just see, M and N, this capacitor is directly connected between M and N. M and N. M and N. So M and N will just join one between M and N. M and N. And then from M point, two more capacitors are coming out in this way, and they meet at P, and from P there is one more capacitor that is connected to N. That is the combination. So what will be, actually these two capacitors are connected in parallel. So when they are connected in parallel, we can write this is M. So this is 2C, this is C, and that one is C. So what it will be, this is basically N. These two are connected in series. So it looks like 2C square by 3C. 2C by 3 will be the equivalent capacitance between these two, and the below one is C. So now you just have to add these two, okay, because they are connected in series. Sorry, they are connected in parallel. So that is 2C by 3 plus C. Just add them, we'll got the result. Now we'll take another example. Let's say these are the 4 capacitors. 1, 2, 3, 4. 1, 2, 3, 4. And this is P. This point is Q. And from that point, this is basically connected. You have to find the equivalent capacitance between the points P and Q, each of capacitance C. How you will calculate, sir? This is Q, so that point will also be Q. This is P, this is also P, that will also be P. Now you have to find the equivalent capacitance between the points P and Q. Just see, P and Q, between P and Q, 3 capacitors are there. 1, 2, 3. And between P and Q, one more capacitor is there. In this way. There, from P to Q, these 3, as well as from P to Q, these 3. This one. So this is the value. So these 3 are connected in series. The value will be C. They are connected in series. So value will be C by 3, and it is only C. So this is basically Q. This is basically P. The value will be 4C by 3. If you add these two things, C by 3 plus C, the answer will be 4C by 3, and that's the answer. Okay. Now we'll solve next one. Let's do one important thing. Let's see, this is C, that one is C. We'll be able to solve any type of problem regarding this. That one. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. One more is connected here. Okay. So this is B. This is basically A. You have to find the equivalent capacitance between the points A and B, each of capacitance C. So now how we will solve it? So this point is A, so that one will also be A. If this is A, this is also A. This is B, that will also be B. That is also B. Because they are directly connected. Now what we will do? That one is A. So that one will be different, not A. Let's say this is P. That one is B. So this will also be different, Q. So now this is A point and this is B point. From A, directly two capacitors are connected. A to P as well as A to P. A to P. Also one is there, but that one is connected A to Q. So from A, two capacitors. These two are A to P. A to P. Now similarly for B, B to Q, B to Q. So let's say that one is Q. So that one is B. B to that one is complete. That one is complete. A to P, A to P, and B to Q, B to Q. That these two are also complete. Now B to P. So how will connect B to P? That one is B to P. B to P. That one is also connected. And A to Q. How will connect this? A to Q. Sorry. A to Q. A to Q. And also one thing, everyone is complete. 1, 2, 3, 4, 5, 6. So what we will do, just see this circuit carefully. Clear? Just match all these things. Now, this is very simple. Now we can write, instead of these two, we can write 2C. So here it will be 2C, 2C, connected with that C, 2CC, and this is A basically. And in the upper part, that one is C, and this two is 2C. So what will be the answer? Actually, that will be A, only 1, that will be B, there is also 1. 2C and C, 2C squared by 3C, 2C by 3, and that one will also be 2C by 3. So the answer will be 4C by 3. How easy this problem is? Okay. Now we'll solve few more numericals, then everything will be clear. Okay. I believe now we'll be able to solve few numericals on it, but still I will give you a few more examples. So let's solve that one. I think that one is the previous year problem of CBSE exam. CBSE. So that one is B, that one is A. Each of capacitance C, you have to find the equivalent capacitance between the points A and B. Sir, that point is B, so that will also be B. That is B, so this is also B. This is 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 B. Now let's see the funny thing. Sir, for this capacitor, the potential of both these ends are same. Why? Because that point is also B, that point is also B. That means this point and these points are same. So when two points are same, that means their potentials are also same. That means there is no potential difference. And according to Ohm's law, whenever there is no potential difference, no currents will flow through it. And when in any electrical components, no current flows through it, then you just have to neglect it. Okay? So we can neglect it. Just neglect it, similarly neglect it. So now what will be the circuit? That A, only one, that one is connected, and that one is B, and that one is only one connected. So CC, answer will be 2C. C and C, answer will be 2C. Okay? Now we'll do another numerical. Let's just change the entire thing. Okay. Now we'll take another examples. Let's take a big one. I will solve the big part. This is C. Each of capacitance C. So we don't need to write. Okay. Okay. 1, 2, 3, 4, 5, 6, 7, 8. And so on up to infinity. The entire combination goes. This point is A. This point is B. Each of capacitance C. Let's see the pattern here. You have to find the equivalent capacitance between the points A and B. How will you solve it? Each of capacitance C. Just follow the combination 1, 2, 4, 8. So the next one will be 16, and next one will be 32, and so on. I think now we can write this thing in this way. This is A, this is C, this is B, that one is C, and these two are connected in series. So what will be the answer? Sir, C by 2. And these are connected in series also. What will be the answer? C by 4. These are also connected in series. What will be the answer? C by 16, and so on. C by 16, and so on up to infinity. So now all these capacitors C, C by 2, C by 4, C by 16. Before C by 16 there will be C by 8, and then the next one will be C by 16, and then next one will be C by 32. So all these capacitors are connected in parallel. So now what will be the equivalent capacitance between A and B? So CAB, that will be C plus C by 2 plus C by 4 plus C by 8 plus C by 16 plus dot 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 up to infinity. So what we'll do here, C is common, 1 plus half plus 1 by 4 plus 1 by 8 plus 1 by 16 plus dot 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 up to infinity. So let's say this is basically an infinite GP series where the common ratio is half. Just find the common ratio. Common ratio is half and the first term is A. So what we'll do, C equal to 1 by 1 minus half. So the answer will be C into 1 by half. So the answer will be 2C. Actually, for infinite GP series, the sum of GP series formula is A by 1 minus R, where A is called first term, R is called common ratio. A by 1 minus R. We are using that formula. Okay. I think everything is clear. Just you have to find the value of potential. Okay, just potential. Let's see the next one. If that point is A, okay, that one is 2, that one is 3, sorry, that one is 3, and that one is 4, that one is 2, okay, that one is B, sorry, we just have to connect all these three. 2, 3, 4, 2, 2, 3, 4. We have to find the equivalent capacitance between the points A and B. So how we'll solve it again? So at that point is B, so it will also be B. This is B, this is B. Now that one is A, so this one will also be A. And let's see, this is A, so that point will be different, B. So how we'll solve it? That point is A, that point is B. That point is A, that point is B. So A to B directly connected to A to B directly connected a 2 microfarad capacitor. That one is 2 microfarad capacitor. So that one is complete. Now from A, 2 capacitors are directly connected at P. A to P, A to P. So A to P, A to P. That point is P. That one is 2. That one is 4. And from P to B, one more is connected. P to B, that one is 3. Now 4 and 2. This 4 and 2 are connected in parallel. So the answer will be 6. Then that one is 3. And the below one is 2. So this is B. This is A. I think now everybody will be. So these two are connected in series. So when you will solve them, then the equivalent value will be 6 into 3, 18 divided by 9. That will be 2. So that one will also be 2. 2 and 2 are connected in parallel. So the final answer will be 4. Now we will solve the last problem. Let's see the last one. This is the famous one. Okay. This is the famous one. We will solve now the famous one. Okay. We will solve the famous one. We will solve the famous one. So each of capacitance C, each of capacitance C, that one is very famous. Okay, each one having capacitance C. Actually, there are 12 ohms, so 12 capacitors are there. Actually, 3 different questions can arise from that part. You have to find the equivalent capacitance between A and B. Let's say that one is A and that one is B. Just imagine these A and B are basically 2 body diagonals of this cube. A and B are the 2 body diagonals of the cube. So the question may be find equivalent capacitance between A and B. Now just imagine this is A and this is D. These two are called sides of a cube. So this is one other question, find the equivalent capacitance between A and D. And another one, suppose this is A, that point is P. So this is basically phase diagonal. AB is the body diagonal, AD is side, and AP is basically the phase diagonal. These 3 are basically the points that may arise from that part. So here today I will solve the AB part, and these 2 will be homework for you guys. Let's see what you learn. So we'll find the equivalent capacitance between the points A and B. That point is A. Let's take a few more space. Okay, there I will solve. That one is A. Why, sir? Why you are doing these things? 1, 2, 3, 4, 5, 6. Why we can connect them in this way? 1, 2, 3. This point is B. 3, 3. That one is. Let's solve first. So that one will be 3C. That one will be 6C, and that one will also be 3C. Now you have to find the equivalent capacitance between A and B. All of them are connected in series. So I think everybody will be able to solve that part. So the big thing that arises that how you will able to make that circuit in this way. Let's see that one. Okay. So just imagine. Let's give their name. B. That one is P, so that one is Q, that one is R, that was in S, that is in T. Okay, so now just imagine you have to find the equivalent capacitance between the points A and B. So A and B, you have to find the equivalent capacitance between the points A and B. Let's say the potential of B point is VB, let's imagine, and the potential of A point is VA, let's imagine. Okay. Now from A point directly 3 capacitors are connected directly. From A point directly that capacitor is connected at D, directly that capacitor is connected at T, and directly that capacitor is connected at R. So D, T, R, these 3 capacitors are directly connected. So just imagine if you want to consider these things as resistors, if that thing is easier for you, you can also consider instead of capacitor that these are resistors. Suppose these are resistor. Everyone is resistor. So what will be then? Then from that point, equal amount of current flows because each of capacitance see na. So if you consider resistor, then each of resistor will be same. Each of resistance will be same. So from that point, equal amount of current flows because how much current flows, it depends on the value of resistance. So equal current, if equal current flows from there, so equal potential drop will be there. From that point, if same I current flows in this way, I in this way, I in this way, and each of resistance are same, then equal amount of drop will be there at D, at T, at R, equal amount of potential drop will be there. That means the value of potential of that point and that point are same. That means R or T or D, they are basically equipotential points. So this point is basically R or T or D. These points are called basically equipotential points. Similarly, for B, directly connected points are Q, S, and P. Q, S, and P. So these points are also equipotential points. So these points are Q, S, or P. They are equipotential points. These points are Q or S or P as you want to wish. So these capacitors are gone. They are already connected. Now these 6 are left. Just see here Q to T. This side Q, this side T. This side Q, this side T. So Q to T. QR, this side R, this side Q. R S, this side R, this side S. R S. Now TP, this is T and this side P. So T and P are also connected here. T and P. PD, this side D, this side P. So PD is also connected, and SD. That one is S, that one is D. So all we can consider in this way. So on the basis of the value of potential, you can also calculate the value of equivalent capacitance for every case. Okay. Now you just have to practice all those numericals by yourself. Once you will be able to understand all these things are very easy because we are using the easiest and basic concept to solve all those things. Clear? So we'll see you in the next video, and I'll make a second part of that video where I will solve some different type of numericals on the basis of combination of capacitors. Okay.